Namaste all. Hope you all are doing good. So far, we are going through all the videos and playlist of the blockchain name Namaste Crypto series, and from today's demonstration onwards, we are going to do the actual programming on Solidity. So before that, I hope you have seen this Namaste Crypto series, and if I open this, we have discussed so far everything conceptually about how blockchain works and the terms around it, some algorithms, what is the actual flow that is happening, and in between we have seen the history, the flow, what is the future scope, and all those things we have covered here, each and every term. So all this is not for sure required to do the Solidity programming that is we are going to start from today onwards. But if you know that thing, it would be very clear picture you from the, like you will have a very clear picture from the very beginning. So without spending much time, if you are interested, you can watch these conceptual videos. If not, you can directly start the programming. It's up to you. But there is no such prerequisite that you need to know because we are going to start from the scratch. Now, there's one more thing I want to point out is we see every language has many tutorials and we follow those tutorials as per our requirement. But the point is the sequence of the topics is good. Sometimes it's a bit clumsy, sometimes it's excellent, and sometimes there's a possibility that we missed one or two topics in between or the sequence is different. So to avoid any such kind of issues, I'm going through the exact documentation, like the sequence, the concept, the even the examples, the snippets, everything I'll be taking from this Solidity documentation only. So I'll put the link in the description as well, or else you can just Google it, Solidity documentation. Okay. Now, at some point of time, if you are not able to understand something in the video, you can refer documentation. If you are not understanding something in the documentation, you can refer the video. So that's up to you. And I'm not going to put anything extra apart from the documentation. So this I'm clarifying in the beginning itself, because then people will say it's already present in the documentation. So it's up to you where you want to refer, how you want to refer. But the demos that we are going to showcase in the Solidity program, it's completely purely from the documentation. So let's get started with that mention. So if I see the official documentation, I can see some definitions, and it is curly bracket language, means the opening, the closing, everything is like C, C++, that format. Everything is based on that curly braces. Okay. Then it is statistically dry, supports inheritance, libraries, complex types. So complex means user defined any kind of data structures. Okay, or structs. When deploying contracts, you should use the latest version. So we are going to see what is a compiler, how we compile, how we deploy, what are the contracts and everything in few moments. So there's too much index that is given getting started and everything you can refer. But what we are going to cover today, let's point that out first. So we are going to understand what is the smart contract. Only one topic that we are going to cover today is understanding the smart contract. In that we have three subtopics. So a simple example smart contract is we are going to refer, and blockchain basics, because the third subcategory, the Ethereum virtual machine, it's kind of a theoretical. So I want to use some animations or diagram while showcasing the concepts of Ethereum virtual machine, which shows what is accounts, transaction, gas, message calls, delegate, memory, storage, what all different types of storage and all that we have. So with that being mentioned, you can see in the left hand side menu, we are going to cover only a simple smart contract and the blockchain basics in this first demonstration of the Solidity. So first of all, they are given us a small snippet. Now we are going to copy this, and for running anything, either we can use online platforms or we can run in our setup in our local system. So for now, we are going to use the online platform, which is Remix IDE. So Remix IDE. Now open the first link. This is Remix IDE, and then let's wait for the, well, okay, we are going to use the Solidity. Okay, I'll ignore all the other folders as of this moment. We are going to touch base on that later on. So in the contracts, let's say you can see these files, right? So dot sol means Solidity files. Okay, just like dot c is. Okay, now I'm going to remove everything and paste the snippet which I got from the official documentation. So if I go through this, I let's try to understand one by one. So this is going to be very basic in the beginning. Later on we'll jump we'll take a good jumps and deep dive into some complex topics. Okay, I hope the font is visible, otherwise let me zoom in a bit. Okay, so the first line is SPDX license identifier GPL 3.0. So what it means is, when, let me minimize this a bit. Yeah, this much is enough. Okay, so this is basically a pointer for the machine, that here you can find the license of it. So let's say, what is the importance of it? So this is kind of mandatory for the Solidity files. If I remove it, okay, and in the left hand of options, we see huge number of options. We have discussed this on a surface level previously, but we'll discuss deep about each option as and when required, and for sure we are going to cover everything. So as of now, I just commented or removed the license, the first line, and we are going to go into our compile thing, and we are simply going to say, okay, let me minimize this. Let me see, is it visible? Yeah. Compile storage.sol. So if I scroll down, you can see a warning that SPDS license identifier not provided. Before publishing, consider adding this statement and use this for non-open source code. Please see this, okay? So I can see a warning as well here. So warning, the same warning. So I'll redo that, and GPL 3.0 I added. Now, so basically it's kind of mandatory that we mention the license identifier if it's not an open source. Okay, then we have pragmas, and then some stuff. So what does pragma does is, it tells the compiler what kind of code is written in the file that it is going to compile in a moment. Okay, so here the meaning of this is that we are going to use the Solidity compiler, whose version would be greater than or equal to this 0.4.16, and for sure less than 0.9.0. So the reason for mentioning the versions or the ranges, that it should be compatible with some range, that is what we are given. But why we are, let's say, why we are giving this restriction that it should be less than 0.9.0? Because if you see what is new in each version of that Solidity compiler, you'll see some new features, some security fixes, some bug fixes, right? But with every new feature, there are some things which are breaking in the old features, or in the new features, or something is breaking. So to avoid such issues with the code that is written in the some different compiler version, breaking it into some new compiler version, so to avoid any such conflicts or compatibility issues between the compiler versions, we mention explicitly that this is the exact version, or the it should be above this version, less than this version, that kind of scenarios. Okay, so now we have added everything. Let's try to compile again. We'll scroll up, compile storage.sol solve. With that mentioned, let's move on to line number 4. So here we are starting the contract with a curly brace open, and we are ending the contract with a curly brace close. Now, if you have worked with any other language, you might have heard about encapsulation. You might have heard about class. So let's take an example of Java. In Java, we try to implement encapsulation by using class. Now, what is class? Don't use jargons, please, please, please. If that is your request, again, let's forget everything. Basically, encapsulation is one of the pillars for maximum of the language. So what is it? So it's basically a grouping of code, or grouping of a logic. It's basically grouping of variables and all its relative methods, or we can say vice versa. The group of related methods and its variables. Overall, when we say that variables and its related methods, what does it means is, the methods which are going to manipulate, for example, updating the variables, setting the variables. So the group of variables and its related logic or methods grouped together, we call it as encapsulation, which is implemented in Java using class. In Python, with in Python also it is class. In Solidity it is contract. Okay, so it's not a literal some big jargon. It's just a simple implementation of encapsulation. I hope that is clearing some fog in your picture. Let's clear this picture more and more. Let's deep dive more going forward. Okay, so we have given that I'm going to write a contract. The name of the contract is simple storage, and here now we are simply defining a variable, and we are using the set and get. I think this is a straightforward. So let's focus what is new here. So I'm saying function, and then set uint. If you're not sure what is uint, it's unsigned int, means as a positive integer only. Now I'm saying public, so it is publicly accessible. Makes sense? We'll see a demo of that, what is public, who is going to access it in a moment. But as of now, we are saying this is an unsigned int storage data declaration. Now, because I did not mention public here, it's not public, so I need to explicitly provide a function get and say that this function is a public, which is view, means you cannot modify the variable using this function. This function is going to return an unsigned date, and what is that? The stored data. Similarly, the set function is going to set the unsigned. Straightforward, I will not spend much time on this. Now let's go to the fourth option here. Okay, now let me, I hope now this is fine for you. So in the environment, you see various options, and Nash we are going to use going forward after few demonstration. And for now, we are not going to touch any of this. Instead, after Nash, we are going to use MetaMask. If you are not aware of any of this, ignore, forget everything. Simply stick to the JavaScript virtual machine, and you have these many accounts. So we are sticking to the first account, which is having 100 ethers. Now, if you know what is gas limit, excellent. What is the value? What is way? Know what is way? What is way? Everything we have discussed in that conceptual part. So you can refer that for sure. You will find definitely useful. And then, if I scroll down, you can see currently you have no contract instances to interact with. Basically, we did not enter deployed any contract. So we can see I have one contract ready to be deployed, and I'll deploy it. Now before I deploy it, let me show you the balance of this is 100 ether. So I deploy it now. Oh, there's something happened here. We'll see what is that. Let me zoom out a bit. I hope this much font is visible for you. Can't I just zoom in this much? Let me say, yeah, this is good. Why I was doing all this unnecessary things before. Okay, so now if I try to see the balance, I see there is some reduction in the balance, and I see some transaction happening in the logs. So okay, let's try to see the logs first. Okay, I see there is one transaction happen which shows a green tick mark. Now if I open this, I can see there is some transaction cost, and there is some execution cost. We'll try to understand the difference between, but here it is 125,677 gas that is consumed. Okay, now what is the gas price here? If I see, I think it is set somewhere. So you know how to get the gas price, and how to get the cost price based on number of gas units and the gas price. So finally, this much cost is associated with the transaction that we did. What is the transaction that we did is deployment of the contract on the EVM is also one transaction. Now if I open the account, 100 minus this 125,677 will get this much. Okay, yeah, this is good. Now if I see deployed contracts, I can see there's one deployed contract. Let me expand that. You can see a get variable. Now why? Okay, let me minimize this now. Let me just clear this. We have the deployment cost already. Now if I see here, the set is of type public, that's why it is visible. Okay, now get is also of type public, that's why I'm saying get. Now I cannot modify anything because it's of view type. Let's click on get here. So you can see that I got the value as 0, and if I try to see the instruction what is there, you can see the execution cost is 23501. But now let's go to the account, and we see we don't see any difference here. It's the exact same amount. If you don't, okay, let's see 74323. We'll try to get this again, and if I see it's not changed, right? We'll clear this thing. We'll try to understand what just happened. Now let's say we are going to set some value. Let's say the value is 123, and current balance is, let's say, 74323. Now I'm going to do set. I can see something happened, and I can see transaction cost, execution cost, and you can see in the balance also the exact amount is reduced. Okay, now I'll clear this out again. I'll say get again, so I can see 123 is returned now, but there is no difference in the balance. So now I hope you know how to deploy the contract, how to use these methods. So we are good here, and you know how to see this logs. We are going to discuss more on these logs going forward, but for now let's try to understand the first step. So what happened here? Get set all good, function set, everything is good. Now, the point to understand is when we are saying get, that is, we are trying to access a view function. So, we are not actually modifying anything, right? We are just trying to read it. So, when we are not modifying anything, we will not be charged. But when we are modifying or doing the transaction, so when we are using the term transaction in terms of EVM, that is Ethereum virtual machine, it means you are modifying something, and because you are modifying something, you have to pay something. So that's why when I click on set, you can see the reduction in my balance based on the transaction cost. And get, I click on 100 times, there is no reduction in the amount. I hope that is clear so far. If you have referred those conceptual videos, it would be very straightforward for you. Otherwise, I still hope that it is clear for you. Okay. Now let's go. So this was the basic smart contract which we tried to find what the errors, we did some mistakes, we tried to deploy when we tried to use it. Okay, now let's scroll down a bit, and we see subconcurrency example, we see one more example. So we'll just try to understand this example now, and will not spend much time because now you have understood the example one, so this should be straightforward. So let's replace this and zoom this out a bit. This Oh no, this should be fine. And let me minimize this part so you can focus on the code. Okay, so now you know line 1 very clear, absolute clear. Line 2 absolutely clear. Here you are saying greater than 0.8.4. Here this is called greater, and you are not talking about the zero part, you are talking about the minor versions. Okay, so this means greater than. Okay, now here you are writing a contract whose name is coin. Now this thing address public minter. So you are simply defining a variable called minter which is publicly available. Now since it is publicly available, you can see you will not write a get function for this. Are we writing get function for this? No, I don't see get minter because you have already written public here. And what is the type of this address? So what is the type address means? So just like string, integer, double, data types, address is one more data type which once set we cannot modify. Okay, so for what all use cases can we use this? We can find it in the documentation. So let's see. The address type is 160-bit value, does not allow any arithmetic operation, suitable for storing addresses of contract, hash, public keys, private keys and all. So basically you got the point. You cannot modify it, play around with it. Once set, and what kind of value should we set, what is the purpose of address, I hope you got it. But this is one more inbuilt data type. Now next we have mapping address of unsigned int public balances. So this is the variable name, this is its access modifiers, and this is its data type. Now what is this data type? It's basically a hash table where the key would be the address and the value would be an unsigned int. In our case, this unsigned int is nothing but the amount that the address or the account is having. Okay, then we have event. So what is this event? It's basically when something is happening in the contract, the events are generated. Let's say you shut down, so shutdown is an event. You started some application, that is an event. Similarly, if something is happening here, uh, we emit the event. So basically, if you are able to understand here, fine. Otherwise, wait for exact 30 seconds and you'll get it. So let's say there is an event called sent. Now, what is this sent? Basically, we are transferring the amount from address to the different address, and the amount is this much. So when the transaction is happening, I'm going to emit this event called send, and people who want to listen can listen to the events. Okay, so if you understood, excellent. If you didn't, just wait for 30 more seconds. Then we have a constructor. So minter is nothing but our actual message.sender. And who is message.sender? Let's see. Code is only done on the contract. Now message, is this defined somewhere? Yes, this is coin, this is the constructor, and this is the message.send. So this is the person who is deploying the contract. Okay, and his address will be stored in our minter. So if you can see, the type of minter is nothing but address. Now there's one more function which is simply called mint. Here we have receiver and the amount. So what we are doing here, we already have a sender who is the deployer of the contract, and we are, if we send the money by the contract deployer, the balance of the receiver would be increased. That is what we are doing. So ignore why we are writing this, what is the flow, what is the use, ignore that for this demonstration. Just try to understand how what all things we can write and how we can write. Okay, next we have some error defined here. Error allow. So we have seen the address data types, we have seen the mapping data types, and this is not a data type. This is, let's say, uh, a concept. Okay, I cannot say a concept. Let's say this is one implementation. It's not data type, but this is one implementation. And similarly, we have error. Now let's see when we are going to use it. So we have a function called send. So make sure this send is an event and this is not sent. This is send a function. So send, what do we need? A person who is sending, a person who is receiver, who is receiving, and the amount. So we can see receiver and the amount because the sender we already have, which is nothing but our deployer. So if there is insufficient balances, then we are throwing the error. Otherwise, we will simply say reduce the amount from the center, increase the amount from the for the receiver, and emit this event called send. I hope now you are able to call this because the event is already defined on line number 12. Okay, let me minimize a bit. I hope it would still be visible. No, I don't want to take risk. I'll keep it on the same font. So now here we know who is sender, who is receiver, how much amount, and we have defined an event, and we are going to use emit it as and when it is required. So what is the use of this emitting? So people or the other contracts which wants to listen to what is happening here can simply subscribe to the events, or I if I rephrase this sentence that I said, can listen to the events. Based on that, they can decide what to do. For example, let's say I'm sending the amount here. Okay, now that needs to be informed to a different contract. So they'll simply listen to the event called send. So it means the other contracts will get to know that there is some updates happen to the balances of some two accounts. So basically, that was just a dummy use case. But similarly, I hope you got the intention of the send. And similarly, insufficient balance, you can see we are using a here. So when we throw this error and we say revert, if any action is taken, those action will be reverted. I hope you know what is the revert, you know what is compensation, you know what is at the rate transaction. So do the complete thing or do nothing. It's basically do all or do nothing. Okay. So that was all about these two examples that is given us under the a simple smart contract. Okay, now if I scroll down, we'll just take 2 more minutes and we'll wrap up the demonstration one. So blockchain basics. So this transaction, we have just understood this now, that transactions means there is two context in which we talk about transaction. One transaction is when we are trying to modify some variable, we pay some amount. Because we are modifying something, we pay the amount. That is one transaction. But here we are talking about the conceptual transaction. So here conceptual transaction means either do completely or do nothing. If you're stuck in between, revert or do the compensation and come back and basically stay on to your original position. Basically revert all your things. So transaction is do complete or do nothing. Okay, next we have blocks. So again, this blocks we have covered in the conceptual videos. So what blocks says is it basically have all the list of transactions, and then it is getting verified by huge list of miners or minters, and once it is verified, we are adding it as part of the big chains, and that is where the term blockchains. So I'm not going into deep here because I already covered it with the good animations and drawings and all the examples with the real world. So please watch the conceptual videos and to understand this. And that's all for today. Next we are going to cover about the Ethereum virtual machine. Now if I go through that, it would be very theoretical, which I don't want to bore you up with. So if you are curious enough, you can go through this documentation. Otherwise, we'll take some good example and try to understand in the upcoming demonstration. So that's all for today. And once again, the series, the Namaste Crypto series, do watch it in your free time. It's filled with animations. I'm trying to explain by correlating it with the very real world entities which you are using in your daily basis. And for sure, I'm 100% sure your concept, your picture would be very much clear. Not only programming, but the actual working, the mechanism that is happening underlying when you're writing every code, basically. Okay, so that's all for today. And what is it that I'm expecting from us? Subscribe, comment, like, share, and mention in the comment section if you have any queries or any feedback or any questions basically. If I'm aware, if I can answer it, I'll try to. Otherwise, the other viewers will try to answer it. Okay. And you can reach out to me via different mediums that I have provided on the about section. You can follow me on the Instagram, the Dpoint YT that you can find somewhere. I don't know where you might find it somewhere scrolling, or you can find it in the about section of the channel or in the description. Similarly, we have a Facebook page, we have a Discord channel where people are communicating for different queries for different topics, not only for Solidity. So all those details you can find, and if interested, you can join. So with that mention, let's meet in our next demonstration. Thank you.